Welcome back. This is our last section from the first unit. And we're going to be going over box and whisker plots. We're going to learn how box and whisker plots summarize large data sets using five key values that I believe we've gone over in the previous lessons already. But those values are the minimum, the first quartile, the median, the third quartile, and the maximum. And we'll practice creating box plots, reading and interpreting them, understanding the quartiles and what they mean, and identifying possible outliers as well. We'll also be able to, by the end of this lesson, describe the center, spread, and overall shape of data using a single graph. So let's take a look at our first question on box plots. This question actually is multiple questions in one, and I think it's a great question to start with. So it's asking us which of these data sets could be represented by this box plot. And so we have to analyze all four of these data sets in order to determine which of those four matches this graph or this box and whisker plot here. So let's take a look first uh, at the midpoint. And before we do that, it's always good to look at if these are in sequential order or not, if our answer choices are in sequential order. And it looks like they've already ordered them from least to greatest for us. So that saved us, I think, a significant amount of time. But now let's look at the midpoints of these. So we're going to use our method that we talked about in our last lesson, where we're going to cross off left, right, left, right, left, right, left, right, until we get to a midpoint. And here we've got two values in the middle. So we've got to find our midpoint by adding those together and dividing by 2. All of these data sets have the same amount of individual data points in them. So we can say that all of these are the midpoint. So let's start with the midpoint. So this is going to be for the midpoint. We're going to just say 30 plus 34 and divide by 2. And this is for A. So that's 64 divided by 2. That's going to be 32. Okay. For B, we're going to do the same thing. 32 plus 34. Divide by 2. And that's going to give us 66. That's going to be 33. For C is going to be 30 plus 34 by 2. So we get 64 for 2 is 32 for our midpoint. And then lastly, for D, also 30 plus 34 over 2 gives us 64 over 2, which is 32. Okay, so this is our midpoint on our box and whisker plot, that line right there, and it's showing us that's at 32. So we can cross out answer choice B. I'm just going to put an X on it like that. And I'm going to leave our medians right there. Or excuse me, our midpoints are, actually I should have said median instead of midpoint. Yeah, those are our medians. Okay. Next, we're going to look at the endpoints. So the endpoints, you just scoot this up here. Our endpoints are just those 2 dots on the edge of the graph there. So we have an endpoint at 25, and we have an endpoint at, looks like 38. These are all going up by 1. I was just double checking the scale there. So we have endpoints at 25 and 38. So it looks like A checks out, C checks out, and D is not. We do not have 25 and 38 on our 2 ending values, and those correspond there and there. So not D. These do not match up. Okay, so we were able to cross out B and D. Now let's take a look at our quartiles. So we talked about quartiles in the last lesson. So we're going to check where is Q1 and where is Q3. Well, Q1 is going to be right here on our box, right on the outside of our box, and Q3 is on the other outside edge of our box. So Q1 is at 29 and Q3 is at 35. So now we're going to take a look at, well, what are our quartiles? Let's see if we can find what those are. So using our data list, we're going to separate it down the middle. Our median is at 32, so it's between these two numbers that we found or that are in the middle. Let's get rid of these boxes. Oops. Let's get rid of these boxes here. I'm just going to completely cross this out so we don't have so much data to look at the same time. We're going to split that down the middle there. Okay, now we're just going to find what Q1 and Q3 is. It's going to be the median of the lower half for Q1, which for this first one is 29, and for Q3 is 35. That looks like a match. Let's take a look at C. We've got 28 is our middle number and for Q1 and then 37. So it looks like C is not correct. So we've got our final answer for A. And I think this is a great example because now we can look at all of these different properties of box and whisker plots, the median, the endpoints, and the quartiles. Let's take a look at one more. I think this next one's a little bit quicker. Here we just have one data set to analyze, and we need to match the box and whisker plot now. So it's in a different order. So uh, the first thing I notice is that our data is already in sequential order. I'm just going to say our data is in sequence. So that's a good thing. Now we're going to check the midpoint of our data here. So you zoom in just a little bit. We're going to use our same method, crossing out left, right, left, right, left, right, left, right on each side of our data, starting with the outermost numbers and working our way inwards. And it looks like our median is 6. Okay, now we're going to check our endpoints. And again, we're using our data set first, and we're comparing it to the box and whisker plot. So our endpoints on the data set are 2 and 11. So 2 and 11, it looks like A is 2 and 12, so not A. Cross out A. B is 2 and 11, and C is 2 and 11. And earlier we found our median. It looks like all three of these have a median of 6, so we had nothing to cross out for step 2. Okay, so we've at least narrowed it down to 2 answer choices. Now we're going to check our quartiles. And we have one median here, so that makes it nice and easy. We can just check our quartile. Our quartile here, though, our first quartile is 3 and 5 is our middle number. So for Q1, that's going to be 3 plus 5 divided by 2, and that's 8 over 2, and that's equal to 4. For quartile 3, we also have two middle numbers, 8 and 8. That's a little bit easier. That's just 8, but just to show you the math, it's 8 plus 8 over 2. That's 16 over 2, and that's equal to 8. So these are our outer edges of the box plot. We're looking for 4 and 8. It looks like for B, it's at 3 and 7. So we can cross out B. That's not right. And then C is at 4 and 8. Looks like that's going to be our final answer for this one. All right, on to reading box and whisker plots. Um, these go by a little bit quicker, so I think we're going to do maybe one extra example for this. This first one just wants us to find the median. It just wants us to find the median of the data, and the median again is this middle bar in our box and whisker plot, so the median is 6. Okay, that one was fairly simple. The next one says find the interquartile range of the data. And we calculated this in our last lesson as well. Just as a quick reminder, the interquartile range is quartile 3 minus quartile 1, or Q3 minus Q1. And this tells us the spread of the middle 50% of the data. Just going to write that out. Spread of the middle of the 50% of our data. Okay, so Q1 is 4. That's there. And on the other side of our box plot, Q3 is equal to 7. And so we're just going to plug that into our equation for the IQR. Very straightforward, 7 minus 4. And so the IQR is equal to 3. And that's all it wanted us to find for this. What was the interquartile range, or the IQR? 3 years. And I'm skipping the word problem. If you want to read those, you can. But for this, really, we're just looking at the question and interpreting what the box plot is. Just matching the box plot to whatever the question is. This next one is on range. We haven't really gone over range in this class yet. The range is the highest value minus the lowest value. We also write that as the maximum minus the minimum. And so in this one, our maximum is here at 12, and our minimum is at 0. And so our range is just 12 minus 0, or just 12. Okay. Now we're going to start looking at interpreting quartiles. So this has more to do with percentages now. Remember that our quartiles, they split the data into 4 different sections. We have a minimum, quartile 1, median, quartile 3, and a maximum. And just as a quick sketch, I know we've looked at a lot of these so far, but just do a quick sketch again. So there's 4 different sections here. So this is our minimum, quartile 1, our median, quartile 3, and our maximum. And it splits our data into percentages. So you can think of it as splitting it into fourths. So each section is 25% of our data. This question says about 50% of sales managers at Force Inc. manage fewer than what number of accounts? And so this is the number of accounts that each sales manager manages. That's what these numbers are given to us as. And it says about 50% of these manage fewer than what number? So fewer than 50% is going to be all of this data right here. So 50% fewer than the median. The median is 50. So this one is 50. Another way we can think about it is the median divides the data into 2 equal halves. So about 50% of the values are less than the median, and about 50% of the values are greater than the median. That's just another way we can think about this. Okay, we'll look at the next problem here. It says the following box plot summarizes the number of years of experience for each Carlson High School teacher. About what percentage of Carlson High School teachers have more than 11 years of experience? So let's take a look at where 11 years is. Looks like it's right there at Q3. Each quartile, again, is 25% of the data. So let me see if I can maybe section it off like this. Just for illustrative purposes, we don't normally write on here like this, but if we section it off like that, we can say that's 25%, 25%, 25% of the data, and this is 25% of the data. And it says, what percent have more than 11? Well, 25% have more than 11 years. Okay, we can also think of it as 75% have less than 11 years of experience. Either way is fine there, but that's how the question's phrased, which teachers have more than 11 years of experience. Okay, the next example here is saying that this box plot summarizes the number of teams in each fantasy football league that Naomi participated in. What percent of Naomi's fantasy football leagues have fewer than 8 teams? So now we're looking at 8 teams. That's at Q1. Again, if we separate this into sections, this is 25% in each of these sections. And we're looking for fewer than 8. Fewer than 8 is everything of the data that's less than 8. And remember, it's not all the way to 0. It's less than 8, and it stops at the lowest data point, which looks like in this case is 6. So 25% have less than 8 teams. All right, we're next going to look at identifying outliers. And now we're going to have to use a formula in order to solve these. Um, there's something called the 1.5 IQR rule, and this is a method to identify potential outliers. So if we're given data and we're given the minimum, the maximum, uh, the quartiles, and the median, we still need to think about what potential outliers are, because a lot of times it's not a good idea to make generalized statements about the outliers of data. And outliers can also skew our data if we have a fair amount of them. They can pull the median or the mean up or down, depending on the number of outliers that there are. And so we use this rule called the 1.5 IQR rule. And the 1.5 IQR rule helps us to figure out what those outliers are. Remember, those outliers are they're going to be on, oops, they're going to be on they're going to be on the outside of our box plots. So our potential outliers are going to be somewhere around here when we find them. But the 1.5 IQR rule is we have a lower fence and we have an upper fence. And the lower fence is to find low outliers and the upper fence is to find high outliers. And there's two different equations for them. So for the lower fence, the equation is whatever Q1 is, and then we subtract 1.5 times the IQR. That's how we calculate the lower fence. For the upper fence, very similar, but it's Q3 plus 1.5 times the IQR. And the reason we're adding is because we're figuring out what's going to be above Q3. And when we subtract for the lower fence, we're figuring out what's going to be below Q1. So that's why those equations are slightly different. But this is called the 1.5 IQR rule. So in order to do this, we have to calculate what the IQR is. So that's going to be our first step. And luckily, they tell us the minimum Q1, median, Q3, and the max here in our data. So we're going to use our IQR is Q3 minus Q1. So that's 42 minus 31. So our IQR is equal to, looks like 11. Okay. Now, I didn't even read the question, so let's go back to the question. I need to slow down here. Let's read the question here. It says the following histogram summarizes the ages of the 25 employees who work for Elon's company. Here's the 5-number summary for these data. According to the 1.5 IQR rule, how many low outliers are there in the data set? So when I first did this problem, I started calculating all of the outliers. I calculated all of the lower ones and all of the upper ones, and then I added them together. That is not what these questions are asking us. They're going to ask us either to find how many low outliers or how many high outliers. You might get a question that asks how many outliers altogether, but just keep that in mind that the questions are going to be either low or high most of the time for this section. All right, so we have our IQR. We want to know how many low outliers there are, and so we're going to use our lower fence formula. I'm going to use that formula there. So Q1 tells us is 31. It tells us there in our table. Q1 is 31 minus 1.5 times our IQR, which we found to be 11. 31 minus 1.5 times 11 is 16.5. 31 minus that is 14.5. Okay, this tells us that our outliers are, we'll say X less than 14.5. So any data point X that is less than 14.5 would be considered a low outlier. Okay, now let's take a look at our histogram. We're looking for things that are less than 14.5. Here's what our histogram says. It tells us that we have one data point, it says one employee that's between 10 and 15 years of age. Our outlier says that it's an outlier only if the age is less than 14 and a half. From the histogram alone, we don't know that it's less than 14 and a half or not. We just know that that one employee is between ages 10 and 15. So we've got to take a second step and look at our 5-number summary down here on this table. The table says that the minimum is 13. That means that we do have one employee who's 13 years old. And that just so happens to be this one bar here. So we can identify that this one bar is one employee who's 13 years old. So that means that we do have one low outlier, the 13-year-old employee, because he's less than 14 and a half years old. Okay, that was, I think, one of the tougher examples, but I think it's good that we've gone over the formula for both lower and upper fence. And then I like starting with this example because we're checking the histogram and the 5-number summary, and we're making sense of it all together. Okay, the next one's going to be very similar, but we have a stem and leaf plot. And a stem and leaf plot is just another way to represent numbers differently. It says key 1 and then a line and then 8. That means 18. So for this first row here, if you're a little bit new to these, I'm just going to write out what this first row is. You can think of this as the tens column. The stem is the tens column. The leaf is the ones column. So for stem and leaf, for this first section here, this would be 13, 18, 19. And it's just another way for them to write those numbers in maybe a little bit of a shortened method. Okay. So this is very similar to a dot plot, but it's a stem and leaf plot. And you've probably seen these in earlier grades as well. All right, let's take a look at the question here. We have species of turtle. There's 18 data points here. And it says, here's our 5-number summary. I'm just trying to zoom out so we can see all of this at once here. And if it helps you to take a screenshot of this, I think that's probably good. That way you have the entire problem there so you can see it. And it says, according to the 1.5 times IQR rule for outliers, how many high outliers are there in the data set? And we got our 5-number summary. Okay, so again, we're going to use the 1.5 IQR rule. And we're going to calculate the IQR for step 1. Okay, so the IQR, we've done this, I think, several times now, so this should be a good review. Is Q3, it tells us, is 40 minus Q1 is 24. So the IQR is equal to 16. Okay, now we want to find the high outliers. So that's our upper fence equation. And the upper fence equation is Q3 plus 1.5 times IQR. So that's going to be Q3 is 40 plus 1.5 times our IQR is 16. So we've got 40 plus 24, and that's equal to 64. So now we're looking for any value x that is greater than 64, and that is going to be considered a high outlier. Okay, so now we're going to check the stem and leaf plot. This is our third step, and I think I forgot to write step 3 earlier, but that's just check the graph or the data. I'm just going to say check the data for step 3. Okay, we're looking for if there are any points that are greater than 64. Here's what I see. I see here is 75 and 77. And then there's one more data point. There's 13 in the tens column and then an 8 in the ones column. That's 138. So from the data, I see that there's 75, 77, and 138. That tells us that there are 3 high outliers. So our answer is going to be D for this one. Okay, let's take a look at one more with a dot plot, just so that we are able to look at all the different types of data that can be represented using the 1.5 IQR rule. This dot plot shows a number of songs in Sal's collection. We also have a 5-number summary for these data, and then we want to find how many high outliers there are. Okay, so we're going to start with finding the IQR. That's Q3 minus Q1. And that's Q3 is 13 minus 9. And that's equal to 4. So we've got our IQR. Now we want to find the high outliers. So we're going to calculate the upper fence. And the upper fence is Q3 plus 1.5 times IQR. And I'm just going to write the lower fence formula just so you can see it again. We don't need it for this problem, but the lower fence formula is Q1 minus 1.5 times IQR, just in case you need to see that again. I'm just going to kind of write that to the side here. Okay, but we're working with the upper fence. How many high outliers are there in the data set? Okay, so Q3 is 13 plus 1.5 times the IQR is 4. So that's 13 plus 6 is equal to 19. So now we're looking for any data points X that are greater than 19, and that would be a high outlier. Okay, it looks like we have one data point at 20 on our dot plot. that is greater than 19. So it looks like we have one high outlier. I'm just going to say one high outlier for our final answer there. All right, so that is everything on box and whisker plots, as well as identifying outliers.